I'd like to welcome Phil and Nigel today. They are going to be, I just start my video, covering the session on building rule-based OLTP systems using Oracle RDF. So Dr. Phil Cannata received a PhD in 1980 from the University of Notre Dame in high energy particle physics and has worked in computer science industry for over 40 years, starting with doing Unix development at Bell Laboratories in Murray Hill, New Jersey. In the early 80s, his most significant contributions to Unix was the design and implementation of shared memory and semaphores and memory mapped files in Unix 4.2 and Unix 5. He was a research director at MCC in Austin, Texas, and then he worked at IBM, Sun Microsystems, and now Oracle. Dr. Cannata, I hope I pronounced it correctly, has also been an adjunct professor at the University of Texas, Austin for 18 years, teaching data management, data visualization, data analytics, programming languages, data structures and algorithms in Java and Python, software design and networking. He is also an Oracle certified professional and has taught Oracle Database 12, data mining technologies for Oracle University, data analytics, SQL classes, and General Assembly in Austin, Texas. So I'll just jump quickly into Nigel Jacobs. Hi, welcome. He is a senior principal software engineer working on the Fusion application development. He received a BSc from the University of East Anglia and a master's in artificial intelligence from the University of Essex. He has worked in areas such as financial transactions, artificial intelligence, semantic databases, programming languages, data modeling, identity management, and server-side architectures. He has been awarded 3 US patents, and his interest and he has an interest in photography. So thank you. I'm going to pass it over to you guys now. Thank you.
Thank you, Emma, and welcome everybody. And this is going to be, maybe it looks like it's a little bit different, talking about OLTP data in RDF instead of data analytics and machine learning. But I think there's actually a great tie, because if you remember from Alberto's talk, he talked about how hard it was to integrate the transaction data into the graph data that they used for analytics. And just think about the fact that if your transaction processing data was already graph data, you could use it straight away. And as Emma talked about with RDF, you can add inferencing capabilities and so forth on top of the transactional data to make it more semantic and make it easier to integrate with other data sources. So I think there's actually a very good tie. But more importantly, I think this is a secret weapon for developing applications. I'm a data analytics machine learning guy, but I'm also a hardcore database application developer. And this is going to talk about how easy it is to develop database applications using graph technology. And the reason for that is you can put all of the complexity into the database instead of the application code, which means you can actually put all the business rules and application logic into the database. You can actually put, with Oracle's implementation, only Oracle's implementation, you can put all the complexity associated with data partitioning into the database, and you can put application provisioning into the database. So you don't need your typical continuous integration, continuous development, Jenkins process, and so forth to manage all of your application code. So I really do think of this as a secret weapon for developing database applications. Okay. We have all of our code in a Git repository, which I'll put in Slack. It's my UT repository, but I'll be moving all of the code, hopefully today, to the repository that Charlie Berger talked about yesterday. I'm working with Charlie right now to set up that. So I'll probably give you the link to this repository. The repository will have all the code I'll be talking about, all of the code Nigel is talking about, documents which will contain this presentation and a white paper that we've written, and also some OCI code for building an OCI environment in which you can run this code. And I've been working with the people from the the Oracle Startup Cloud group, in particular, Costa Juric, that's helped me with this code. Okay. So if you're going to build a database application today, what do? You build a relational database, and then you have some object to relational mapping technology that builds objects that you can then present to Java code, and then the Java code can talk to your REST API. That's the way people typically think about building an application today. And then you wrap all of that in a microservice, using Docker and Kubernetes and so forth, to build a set of microservices for your application. And this is what we're going to try to convince you this is actually not a necessary way of doing application development. We're actually going to turn this whole process upside down, turn it on its head. And instead of having a relational database, we will have a database that has RDF objects, rules in the database, and then we just build relational views on top of that and expose those relational views to our REST API. I'm going to use a real simple database for this example, the employee department database. Hopefully almost all of you are familiar with it, where you have an employee set of data, 14 employees, and they are in a department. Each department has many employees and so forth. So if you're going to build an application today, and this is what I taught my students for 18 years, you build a conceptual model. And then you transform the conceptual model to the logical model. And then you transform the logical model to the physical model. And then you generate the DDL from that, and you load the DDL in the schema, the DDL, into the database, and then you populate the database, and then you build your application on top of that. And then if things change, you change the conceptual model, you change this, you change this. And if they change, you change this. And so you're constantly redoing this process. And then on top of that, that's your database. You do all the rest of this that I've already talked about. Well, with RDF, you can just have a conceptual model, because RDF is schemaless, as many people have talked about. So, and you can build views on top of this conceptual model, and you actually don't even build the database until you put data into the database. And so if you change things at the conceptual model, you just change the relational view. You don't have to make any changes in the database. So now your conceptual model stays completely in sync with your implementation, which is a wonderful thing to have happen. What you have to build are these relational views on top of the conceptual model. And then what I've done is I've built insert, update, and delete instead of triggers that actually have Sparkle code inside of them that allow the views to do all the CRUD operations to the data. And in principle, all of these views and all of these triggers could be generated, auto-generated, from a simple declarative set of specifications based on the conceptual model. So this is a very low-code model for doing software application development. So then the only thing you really have to write are the set of rules that implement the application. And here's a very simple application. We have our employees. Let's say they are supposed to take some training. And if all of the employees in one department here, the accounting department, have taken the training, then the department is eligible for an award. That's our very simple application. Well, how would you specify that in Sparkle inside of the RDF database? Well, this is it. This is all the code that you would need for this application. You would get the list of employees and their departments. You would minus out, subtract out departments for which employees have not taken training. And then you would build a new variable. This bind operation builds a new variable that says department 10 is eligible for award. Put that into this variable and then insert that variable into the database. And that's it. So your application development really becomes building these kinds of rules. And it's important to understand that Oracle's RDF implementation enables all of this to happen, where I don't think there's any other RDF implementation where you could do this, because Oracle has this very tight integration with SQL, PL/SQL, RDF, and Sparkle. And that's critical. It also integrates very easily with Oracle's REST data service. Oracle's RDF implementation has data partitioning built into it, so you don't have to deal with any of that complexity. Oracle comes with pluggable databases, so it's multi-tenant. And all of the OCI services that Oracle provides an application developer are available to this kind of application. You don't need to do any provisioning. You don't need any CI/CD technology, because the only thing you have to do is update your views in each PDB. And there's very little DBA assistance associated with this technology, because there's no indexing to do. There's no statistics to gather. So it's a very simple solution to application development. And with that, I will turn it over to Nigel, who will talk about how you would do this using microservices instead of what I just showed you.
Hi, okay, let's see if I can get my screen to share. Okay, stop 3, let's see if this works. And excuse me if did that work? No, that's not working. Let's try one more time. Stop when. Actually, excuse me, working on technical problems.
It's perfect, we can see it.
Okay, all right. So, yeah, my background is in RDF and OWL and semantic databases, but I've been working in the Fusion application development area, and I took Phil's idea of the application and decided that I wanted to see, he asked me if I could develop a more sort of traditional, a traditional approach using relational database and the usual stack. And I put it inside a microservices framework, and I've chosen some, so we've got a mix of different technologies, very existing technologies. Java application development framework is a very popular environment to build out the connection between your database, the schema, and your conceptual model, logical model, and the rest. And I put it inside a Helidon microservice framework, which is a fairly new framework from Oracle that's becoming very popular. It's using JDBC and SQL to interact with a Oracle RDBMS, very straightforward. So in this kind of approach, as Phil showed in his earlier slides, we have a complete stack of different layers, all of which have slightly different technologies and require different tools and techniques and languages. So this, which I'm showing here, is the idea that we have the REST API, that's how the microservice communicates with the outside world. And then below that, we have business logic. This is where you're doing all of doing this sort of determining the semantics of the application. That the idea that we're trying to compute for each employee, we're trying to compute the department of the employee and whether or not that department has an award yet based upon the training level of the employees in the department. Then we've got the ORM, which is how do we map that into the tables of the database, and then we've got the RDBMS. So I'm going to dive into this application. All the code is up there. It's still in a prototype form. It's not all complete, but it's going to be up in the GitHub, the Git repository. So we have this in REST. This is an example of how you might interact with this application inside Helidon. We've got HTTP JSON that's communicating over the network. That's being translated into plain ordinary Java objects, domain objects. We're using JSON and HTTP to actually communicate, so through GET and PUT commands. And this is an example of how you would, these examples here are showing you how you would get an employee, how you would get a particular employee, all employees, or how you would put the employee with arguments. This is fairly standard stuff, but this is kind of how it works through the REST API. And then we have business logic. And the idea is that in the business logic layer, we would have all of our high-level semantics. We've got all the actions on the business types. And it's in terms of the domain objects, the POJOs. And then but the problem is, okay, this last point is important. When I built this, and this is my experience from working on other aspects of application stacks in Oracle, oftentimes it's really hard because you have these loosely connected layers to keep keep these areas well demarcated. And in this case, I was hoping to be able to put all of the business logic in the business logic layer up at the top level. But in fact, it all gets sort of pulled down into the ORM layer, into the bottom layer. So the last point is a lot of this logic so this business layer doesn't have much in it other than it's being passed down to the ORM, where we end up doing a lot of the work, as you'll see in a second. So here's an example of these repositories. These are the interactions with the high-level concepts, the notion of an employee and a department. We're getting and saving through with Java objects. So here's the ORM. This is ADF, Application Development Framework. We've got entity objects, application modules, and views. This is I won't go into the details of all of it, but it's fairly familiar if you've done any Oracle application development. It's built out from the database schema, so we can read in the existing relational tables and then build these things around it. And it's done using Oracle's Oracle's development environment, the JDev, with the UI, generates XML files, which you then you can extend the XML and the Java files that are built, the stubs, add your own logic into it. And I found that, one of the things is, because we've got this complex idea of employees and departments, and we're trying to do computation, we want to reduce the amount of interaction with the database. So we end up doing some pull through caches. That's how I've implemented. This is fairly typical. So all of this stuff is kind of the way that a lot of the things that happen inside a typical application stack. Here's a quick graph that shows you how it all looks. We've got employees, departments, we have the views, and the emp-dept VO. This one view is a join of the employment of the emp and dept relate tables that Phil mentioned. Okay, so this is Java code. The important thing here is that we're actually, whenever we do an employee, we actually have to load the employee in. Then we have to load the departments in, if they're not already there, into a cache. And then once we're finally done, we do this we call finalize, which then goes through and computes. It computes whether or not a department has an award, whether, based on the training. That's something that happens for you in the RDF. You express it in the semantics. In this case, I have to write a bunch of fairly ugly Java code to do it. So this is where we're loading the the employees into the cache. This is the low-level ADF. We're making the calls. We're reading rows into the cache. We're pulling the data. This is the joined employee department rows get pulled through caches or maps between the identities of the employees and the departments. This is all in memory. The idea is that we'll just pull it in each time we build this cache up. We're doing this is the kind of thing you see a lot of, where we're mapping from JDBC result sets into POJOs, into domain objects. We're pulling the data out of result sets and putting it into rows, into domains. And finally, this is the finalize. This is kind of the interesting part. But again, it's all Java code. All of this code is trying to figure out whether or not, for a particular department, whether or not the department has the award. At the very bottom of the slide, you'll see it says set award. And the only way you can do that is by making sure that we have all of the employee data for that department loaded. So if we don't have it already in the cache, we have to load it in. And then we can figure it out and completely populate the domain object. Okay, so then this is standard relational database. And the problem here, again, we've got SQL. We have the DDL, where we're creating tables using the standard DDL syntax, but it's something else you have to learn and figure out as a developer. So this is my final slide, but this is kind of the findings from Microservice Approach. We have, when you build one of this complex, a traditional microservice-based application stack, you have multiple formalisms and development tools. And as Phil pointed out, with so many different tools and languages, the development time, it gets really slow, because every time you make a change, you've got to make a change in all these places. You have a lot of different layers. The code complexity is enormous as a result of all of the different tools and techniques. And the loose coupling between the layers only increases the cost of the network traffic. We've got multiple database hits because we're having to go, we can't do it all at once. We have to go out and pull it in. It's not happening on the database engine. It's happening, all the work is happening in the client, and then has to go backwards and forwards. This complicates multi-tenancy and partitioning the architecture. It makes, because we have, we have all these additional security aspects, because it's broken up into pieces, it really complicates things. And the scalability also is not made easy we have in this traditional approach. So I'm going to pass it back to Phil at this point to wrap up with our presentation. But I did discover that indeed it is quite a lot of work and complexity to do it using the traditional approach. Okay, Phil, back to you.
All right, thanks, Nigel. So in summary, RDF gives us a really simple schema management capability. All the business logic is in the database, and it's a very low-code solution potentially if you can actually generate all the views and triggers automatically. Then you just end up writing these rules that I gave you one example of. There's no Java, there's no ORM, there's no XML, there's no Docker, there's no Kubernetes, et cetera, et cetera, et cetera. There's no need, as I said, for CI/CD environment, no Jenkins. The data partitioning is built in. There's very little DBA overhead required for an application that you build this way. You have all of Oracle's enterprise features available to you, PDBs, backup, high availability, disaster recovery, et cetera, et cetera. And here's these last two. The online transaction processing database is a graph database, and it simply becomes your OLAP database. So you don't, as Alberto was talking about, you don't have to transform the data, use data integration and all that to get your transaction data into graph. It's already a graph. And then you can just add OWL constructs on top of that to add semantics and inferencing, and do all the things that Emma and everybody else has talked about, and do machine learning on top of it, et cetera, the way Melly talked. And I really believe this is an ideal environment for startups. That's why I'm working with the Oracle Startup Initiative. And you might say, well, startups, they're not familiar with RDF and Sparkle. Well, that's not quite true. Computer science graduates today are very familiar with the Clojure programming language and the Datomic database, and they run it all the time on AWS. And this is probably the way a lot of applications are going to be developed. And essentially, Datomic is an RDF database. And so they know Sparkle, or what's close to Sparkle. And startups don't have a whole bunch of code that they've already built and maintained and need to worry about moving forward. So I think, as I said at the very beginning, this is a really powerful secret weapon for developing SAS, OLTP, database applications, and then turning that data into data that you can use for machine learning, et cetera. And with that, I think we're done.
Great, thanks, Phil. I see there's one question which I think was maybe towards the beginning of the session. So, do you tend to leverage Shackle in order to formalize RDF objects?
No, the only thing I do is just build an ontology in a tool, and then build the views on top of that. It's as simple as that. I don't have any way. Yeah, I think that's the answer.
Great. Okay. Great. So if anyone has any more questions, you can add them now. So thank you very much. I'm going to hand back over to Hans. So thank you, Phil and Nigel.
You're welcome.